So we've talked about expressions involving two control paths, or two possible control paths. And now let's talk about expressions that involve n possible control paths. So here is an example of a C-based multiple selection statement. So this is the typical switch statement, which is something that you learn in CS103. All right, with a switch and a bunch of cases, and then there's some statements based on whether the case is satisfied. You can execute different statements. All right, so is this in C++ or Java, is this a valid switch statement? And if the answer is yes, cool. And if the answer is no, why? So hit pause for a second to think about this. Okay, so the answer is, well, part of it is okay, part of it's not okay. So the first part here, switch value equals 1 plus 2 minus 2. So the switch statement right here is part of the switch statement. This is okay. This is going to evaluate to 1 plus 2 minus 2, or 1. So this will evaluate to 1. And then value will get set equal to 1. And so value gets set equal to 1. But then also, we're going to return 1. So the total expression itself will return the value of 1. So we're going to switch on 1. Actually, sorry, that's wrong. So we're going to switch on the value, So that part will work. So we'll basically switch on the value. So what we want is case value something, right? If value is something, well, the problem is value cannot, or the case statement cannot have the value of I or j. Those are variables. You're required to have a constant. So this would be an error. This should say case 0 and case 1. Those are the two values that you would have to have there. Or the first one's case 1, the second one's case 0, or it's case any value that's a constant, really. So that's not really a valid switch statement because the cases are errors. You can't have variables there. Okay. How about we take a look at this next statement? Okay. All right, I have to write this one for you. All right, how about this? Switch index, and then case 1, case 3, odd plus equals 1. Sum odd plus equals index. Case 2, case 3, even plus equals 1. Sum even plus equals index. And then defaults. See out error index. And then I'm going to close the switch statement. So I'm just going to zoom out just a little bit so we can fit all this in All right, so that is the that's the program. And what would happen if index was equal to 1? What's going to happen if index is equal to 1? So quick pause to think about it for a second, and then come right on back. All right, well, let's take a look at the flow of execution if index is equal to 1. So if index is equal to 1, we're going to execute that line of code, and then immediately skip past this case and execute this line of code. So assuming, let's say, odd is 0, so now odd is going to be equal to 1, and let's assume sum odd is 0, so sum odd is equal to sum odd plus index, so sum odd is going to be equal to 1. So that gets executed, but we're not done yet. There's no break statement here, so we're going to continue executing, and we'll execute past these two case statements, and we'll add 1 to even, assuming even's 0, even's going to be set equal to 1, and sum even is going to be set equal to 1 as well. And we're still not done. So we'll skip past the default, and we'll see out error index. Error index 1. And so the problem with the switch statement is that we're missing those breaks. So we can fix this by adding a break right here and adding a break. Whoops, I see an error in here. It should be case 4, not case 3. Okay, and adding a break right there. You don't need a break here because the default is the last statement in the switch statement. So now we have a switch statement that makes a little more sense. Depending on the index, if it's odd 1 or 3, or even 2 or 4, we either add to a counter that keeps track of the number of odds and a summation that sums up all the odds, or we'll add to a counter that keeps track of the number of evens, or summation that sums up all the evens. Or we'll print out an error. Makes a lot of sense. You know, you're probably thinking, boy, what a pain. Why do I have to have these break statements? Why do I have to remember to put them in? Well, it's certainly useful, right? If I can accumulate similar case statements that need similar code to be executed, then not having that break statement allows me to execute the same chunk of code for both case 1 and 3. And you can imagine all the other odds, maybe 5, 7, and 9 also get in there. So that's definitely a good reason to allow the user to or the program to optionally put a break statement in or not. But if you forget the break statement, you can have some unexpected behavior. Okay, so is there a better way? And as it turns out, there is a better way. So C# has a really interesting way of handling this switch statement. So take a look at this. So what this does, C# introduces sort of a goto light. Now we already saw with Fortran that gotos can be a nightmare. And again, with Spin, I'm sure you're experiencing this as you try to write code that does any kind of interesting repetition. But in C#, using goto with a switch statement can be really powerful. So case 1 says, all right, if index is 1, go to case 3. So instead of stacking up case statements, you use a goto statement if you have a different case statement that you want a particular case to go to. Right? So case 2 here says, go to case 4. All right, and then case 3 adds 1 to odd, adds the accumulator for some odd, and then hits a break. Case 4 does something similar. Adds even, adds the accumulator for even, and break. even the default has a break, which is great. Okay, so it is a compile time error if you are missing the goto or the break. So every single case statement has either a goto or a break. Otherwise, it's an error. That's pretty cool. I really like that in this language. All right. So let's take a look at how Ada handles the same kind of multiple selector. Right? That's a fancy word for a switch statement, multiple selector. So here's the syntax in Ada for it. Case some form of expression, and then you provide a choice list, and then you provide something that's kind of like default, basically when nothing else is satisfied. All right, so let's take a look at an example of how Ada handles this. So we have something that says type directions is north, south, east, and west. So this is kind of like an enumerated type. And then we've declared something called heading, which is of type directions. And we set up an integer x and an integer y. Then we assign heading to the value of east, and then we initialize x to 0 and y to 0. All right. Now, we have this Ada multiple selector that says case heading is, okay. So if heading is north, we're going to do something, south, we're going to do something, east, we're going to do something, and west, we're going to do something. So when we're done executing this case statement, what is the value of x, and what is the value of y? All right, so hit pause, and let's figure this out now. So x is equal to, well, it's initially 0, so I'll write that down first, and y is 0. Heading is set to east, so when heading is east, we're going to increment x by 1. So x is going to become 1. So when we're done, x is going to be 1, and y is going to be 0. So this is pretty interesting, right? We have here an enumerated type, and you can't really do this in a case statement in some languages. I'm trying to think. I think actually you can get away with this now in Java, but it's interesting because the way this works in Ada, remember I told you that Ada is very type. It's type safe. It also tries to find as many errors as possible, as quickly as possible at compile time, so you don't encounter runtime errors, because it got used for a lot of defense contracting work. So let's talk about some of the rules for how the Ada multiple selector works. So rule number 1 is it's mutually exclusive. So it's quite possible, let me go down here to show you what I mean by that. It's quite possible that I could have said when north, comma, south. That's okay. But if I do that, then later in the code, I can't say when north, comma, east. That would not be okay. So mutually exclusive means if you say north once, you can't say it anywhere else in any of the choice lists. Now over here, the choice lists were just single elements, north, south, east, and west. But there's no reason why you couldn't have multiple choices in a single one list. All right, item 2 is that the choice list must be exhaustive. Which means that for an enumerated type like directions, every single direction has to be listed somewhere. Or we use when others. Okay, when others is kind of like the default. So let's say we had north, south, east, west. We also had northeast, northwest, southeast, and southwest. Well, if we put a when others right here as the last when statement in this case, then that would handle the northeast, northwest, southeast, southwest conditions. If you don't have when others, though, then Ada will say, whoa, hang on a second. You didn't specify all the possible choices for this particular value. Okay, cool. All right, so there's one other multiple selector that I wanted to talk about, which is, the switch and case works really well if you can spell out individual values, but what happens if you have multiple selection and you have a range of values? Okay, let's go back to a little bit of regular screen here. Okay, yeah, so what happens here? What happens if I have, I wanted to say, do different things, if I have something that's greater than 10, let's see, something that's greater than 100. I think I like the way these things are going here. So, all right. So we got greater than 10, greater than 100, greater than 1,000. Oh, I see how I did this. Okay. Let me try this again. So if we have a value that's less than 10, I want to print out ones. If I have a value that's less than 100, I want to print out tens. Less than 1,000, I want to print out hundreds. Okay. So there's no right way to write a switch or a case statement in any of the language that we looked at so far that could handle this situation for a particular value. So, and we certainly have an n greater than 2. We're handling 3 possibilities here. And so most languages have a form of multiple selection using if. All right, so with an else. Okay. The trickiest part is figuring out how that else part works and how an if statement ends, and every language has its own kind of quirky behaviors around that. So if I wrote this code using, let's say, Java, I can say if value is less than 10, then see how about this. It's not print line ones. Else if value is less than 100, then it's just not print line tens. Else if value is less than 1,000, then else is not print line hundreds. Maybe we'll do one more. Else is not print line big. Okay. So in other languages, there's different ways of expressing the else part. So for example, you might see this contracted. Sometimes it's spelled slightly differently. So there's a language that uses else if. Now, why say else space if when you can just collapse it into a single word? I can tell you that the language that did that cost me like a half an hour to figure that out. I could not figure out why I was having an error in that language. All right, so that ends our discussion of selection, both two-way and n-way selection. The next thing we're going to talk about is repetition.